All right, let's look at another centroid problem. Determine the x and y position of the centroid. So x bar and y bar, that's what it's asking us to find. There are different ways I can do this problem. You can use a composite area, being area 1 added to area 2. You still got to do integration. Kind of two areas on top of each other. Or I can do a triangle square that a y equal x squared is deducted from it. I still have to do integration for this one, but these are, I can find it. Or I can just do integration right away. I'm going to do the integration method, but if you want to get practice, you can do these two methods. So either composite area using a triangle and this, which you got to still do integration here, or do a triangle, a square, yeah, it would be a square minus that curve that's been taken out. But I'm going to use integration right away. You recall the equation is integral of x tilde dA over dA, and for y bar, integral of y tilde dA over integral of dA. So for both of these, I'm going to take a vertical element of area, a little sliver of area, which is very, very tiny. It has the width of dx and the length I will have to find out. So let me draw this a little bit better here, a little bit more clear. I'm exaggerating and drawing this very thick, but in reality it is very, very thin. dx. Okay. So for the width of it, this one is located on this curve or a line, just a straight line. I'm going to call this y2, and let's call this bottom one y1. So this is located at y sub 2, and bottom part of it is located on this curve, so the value of it at any point is the same value as this curve, y1. So if I want to write my D area, find that area is going to be width multiplied by length. Width of it is y2 minus y1. Right here is y2 minus y1 multiplied by width of it, which is very thin, dx. I have dx here, so I better change everything in the parentheses also based on my variable with respect to x. So I'm going to plug their equation back in here. So 1, this one goes here, 1 plus x over 2 minus x2. You can write, say, x1 and x2, don't have to, and dx, and that's my dA. So this part and this part is done. I got to find x tilde. X tilde is the distance of centroid of dA to x axis. So right here, this is my x tilde, which at any point is the same as my value x. Okay, I think I'm ready for integration. All we have to do is plug these back in the integral. X tilde, I said it's equal to x. My dA is right here. 1 plus x over 2 minus x squared dx. I have dx as my variable, so bounds of integral go from move on my x-axis. How do I know where do I start? My integration on this area, I start from 0, add all of these dA all the way to this 1 inch. So it's going to be 0 to 1 inch. Over, sorry, this should have been down here. Over integral of dA. So 1 plus x over 2 minus x squared dx. Same bounds, 0 to 1 inch. All right, let's do this integral. For the y, I'm going to skip it. So I'm going to write it a little bit nicer and going through it a little bit faster. X over 2 minus x squared dx. All right. So I have x2 when I do integration. I have x when I do integration. It turns into x2 over 2. Next, I have x squared over 2. So when I do integration, it turns into x3 over 6. 3 multiplied by 2. And lastly, I have x3 when it becomes x4 over 4. Over the bottom, I have 1. Integral of 1 is x. Next, I have x, that's plus, x over 2. That becomes x squared over 4. And finally, I have x squared, which becomes x cubed over 3. I go from 0 to 1 inch. I go from 0 to 1 inch. If you do the math on this one, your x bar should result in 5 over 11 inch. For the y, I am going to use the same element of area for my y. So redrawing this quick. I'm going to use the same element. You can go with the horizontal element too. Does not make any difference in your answer. So for the y, let me remind myself what I need. Y tilde dA over dA. So I need a dA, and also I need a y tilde, which is distance of centroid of this dA to x-axis. All right. The width still dx. The length still the same. So it's going to be 1 plus x over 2 minus x2. Same as before. What is different here then is going to be distance of centroid of dA to x-axis. Centroid is right here. To x-axis, this is y tilde, which is y1 plus y2 over 2. Which is 1 over 2, 1 plus x over 2 plus x2. So this is one way to look at it. Another way to look at it is also this plus this. This one is half of y2 minus y1, and this one is y1. So half of y2 minus y1 plus y1 equals half of y1 plus y2. Okay, so that's how I got this. All right, plug it in. Bounds are still from 0 to 1. Go from half 1 plus x2 over x squared uh, 1 plus x2 minus x2 dx. This is y tilde. This is dA. Over dA, same as before. 1 plus x2 minus x squared dx. If you do the math for this one and do the integration, you will get 83 over 110. So this will be 83 over 120. This will be 11 over 12. And you get 83 over 110. Thank you very much.